So these notes will be for 6.4. Going through slides 26 through 34. We're going to continue talking about normal curves. Again, when we talked about those normal curves, right, it was always involving regions that are 1, 2, 3 standard deviations away from the mean. But what we want to do is now figure out maybe values that are not one of those values, right? How can I find the area between there? One of the ways that we can do that is taking all those values and converting them into z-scores, and then you're able to actually use different charts to kind of help you determine what would that area be underneath that curve. And there's kind of some, like here's a visual representation of it, right? They took all their data points down here and converted them in terms of our z-score, right? In the middle here, our z-score should be 0 if that's considered our mean. And then if we were looking at this value point, I can take that z-score and look at our chart here to help us identify what that percentage would be. Obviously, we're going to be not doing it by hand. We're going to be relying on our TI-83 calculator. It's a much faster and more correct way to go about doing it. And so some of the directions can be pretty simple. We're going to be going to second vars. So we'll click the second button and then click vars. It's right next to our clear button. And then it'll prompt us with this. And we're going to click that option, normal CDF. And we're going to be plugging in some of those values there. And so what we're going to do is on the next slide, we'll kind of talk about what does A represent B and so forth. So on this slide here, I'm going to kind of color code it here. We have our A value down here, and what we call that is our lower limits. Right? What is the smallest value we want to include, right? Sometimes we won't have one, right? So it might go to negative infinity, but we will possibly have a lower limit. The other value, our B, we can kind of use the same idea here, but this is going to be our upper limit. And that would be this value right here. Again, we may not have an upper limit, right? It could be positive infinity, but we'll always have to kind of tell the calculator what our upper and lower limits are. Identifying our mean, which will already be given into the problem for us, and then our standard deviation. If you have an older calculator, you'll see that with the calculator I'm going to be using today, is you'll have to plug these up in order, making sure we put commas in between there. Other graphing calculators, some of the newer ones, will kind of have a list, like your lower limit with like a colon, and you type in the number, and you just kind of fill in the blanks and then click calculate. So you don't really have to worry about the commas. So let's jump into our first example here. We have a survey of women aged 20 to 30, found that their heights were normally distributed with a mean of 65 inches and a standard deviation of 2.5. So I'm going to kind of sum up my data here, right? We know that our mean is 65, and we know our standard deviation is 2.5. And we want to find what is the percentage of men or women that have heights between 62 and 67 inches. So again, this is talking about our lower limit and our upper limit. So I'm going to kind of write it out first, and then we'll talk about plugging this into our calculator. So we're going to have that pop up in our calculator, normal CDF. The first value I'm going to write is my lower limit, comma, our upper limit, comma, our mean, and then our standard deviation. And so that's what we'll be plugging in to get our percent. It'll be a decimal at first, but then we'll convert it into a percent. So if we want to get out our calculator here, we're going to go to second, and then vars is right next to your clear button. And then make sure we go down to the second option where it says normal CDF, not PDF. Click enter. And then mine kind of prompts me of what is going to be going into each spot. Most calculators won't do that, or it might give you a list, but my lower limit is 62, so I'm going to do comma. My upper limit is 67, comma. Mean is 65, and then our standard deviation is 2.5. Again, if you forget to do commas, it'll probably give you an error, or if you mix up the values, it'll give you an error, so you probably just went ahead and typed it in incorrectly. When I multiply that, we get a decimal, right? So then I can easily just say multiply by 100 to get our answer in that percent. So then that's why our answer here would be 67.3%. And we just answered the question there, 0.3%, right? So 67.3% of women have heights between 62 and 67 inches. For the next one, what is the percentage of women that have heights less than 74 inches? So since we're talking about less than 64 inches, that means that this 64 value is going to be our upper limit, and I don't have necessarily a lower limit. So we're going to be kind of thinking back to like, what is the smallest possible number I can have? We're going to do negative, basically infinity. And I'll kind of show you how to write that in or type that in to make it the easiest. So our lower limit is going to be negative 10 to the 99. You may think, why does it have to be negative, especially since we're talking about heights? But we wanted just to ensure that we're taking into account all the area to the left of that value of our upper limit. So I'm going to have negative 10 to the 99. And we'll kind of use this value when we also talk about our upper limit, but just positive. But in this case, our upper limit 64, our mean 65, and our standard deviation is 2.5. So I'm going to go back here, go to second vars, second option, and then start typing in our values. 10 to the 99, 64, 65, 2.5. And again, I can kind of convert in my head what that would be, but that would be 34.5% would be our answer. Hopefully this is making sense. We got 2 more examples to do, and then you guys can kind of start working on your homework. This next one, the life expectancy for somebody living in Africa is 53 years. So that's our mean, and our standard deviation is within 7.5 years. We want to know what is the percentage of people living in Africa are expected to die before the age of 65. You can see that this value that they're giving us is much greater than our mean. So it's probably going to be a high percentage of people who are probably going to die before the age of 65. But let's write it out. We have normal CDF. And in this case, we do not have a lower limit, right? It says what percentage of people are going to die before the age of 65. So that means that our lower limit is going to be, again, 10 to the 99. Our upper limit is going to be 65. Our mean is going to be 53, and our standard deviation is 7.5. So I'm going to go ahead and just use this one I used previously and kind of just edit some of the numbers. So I have 65 here. $53 for my mean, and 7.5 for my standard deviation. So that's why I get an answer of 94.5%, right? It's a very high percentage of people that are going to die and not live past the age of 65 with the data that we're given. And so the next question is asking us to kind of use that answer that we just found. If we did survey 1,500 people, about how many of them would be going to die before the age of 65? Well, that's kind of going back to many problems that we've seen before. We're going to take our total number of people and multiply it by our percent of 0.945. So we would get 1,417 and a half, but we would want to convert that to a whole number. So that would be 1,418 people are going to die out of that group that I surveyed before the age of 65, right? Using the data that I'm provided, right? And maybe more or less in real life, but with the data that I'm given, I can go off that. The last one I want to talk about here is the lengths of human pregnancy. They're normally distributed. We are identifying that they have a mean of 268 days and a standard deviation of 15, right? Again, most pregnancies kind of fall in that same category of how long they're expected to be pregnant, but some people go a little bit more, some people go a little bit less, and that's why we're going to kind of calculate some of this data. So what is the probability that a pregnancy last at least 300 days? So when we read the word at least, that means that our 300 is going to be our minimum value, right? Because it says at least, right? If I said I at least have $200 in my pocket, right? I may have more than that, but the smallest amount of money I have in my pocket is $200. So that's why that's going to be our lower limit. So let's go ahead and write this out. So we have normal CDF. Our lower limit is gonna be 300. In this case, I don't have a maximum, right? I can't just put like, oh, 360 days or something, right? We're gonna do that same kind of value we were doing on the other one, which would be 10 to the 99. This is essentially saying infinity. Our mean, and then our standard deviation. I feel like we've been pretty good about plugging into our calculator if we still need help with that. But again, just going to second vars, typing in these data points, we should get 1.6%, right? So it would be a pretty rare chance of someone's pregnancy going more than 300 days, especially nowadays with advanced medical stuff, right? They can probably get induced and so forth. And the last question says, what is the probability of a pregnancy that lasts at most 250 days? So keyword there, at most, this is now inferring to our upper limit, right? I don't want to go any more days above 250. So when I write this out, I would have normal CDF. Our lower limit, which is what I don't know. So that's going to be that negative 10 to the 99, essentially representing negative infinity. Our upper limit, our mean, and then our standard deviation. Again, I feel like we were comfortable plugging that into our calculator. You can go back previously in this video to kind of see some more examples of that. But if we plug that in, we should get 11.5%. So go ahead and give the homework a try. All the problems will look pretty similar to this one as well, kind of using our percentage that we found. And then I'll be back on Friday to answer any questions that you guys may have.